our quiz was factor these three expressions. Let's start with the first one. Now, you could factor x squared out of these two terms, but you can't factor x squared out of this. Okay, we want to factor something out of the whole expression. Okay, so we can factor x. Every expression has at least x in it. So we can write this as x multiplied by x squared plus 5x plus 6. Now, in anticipating what we want to do just a little bit later in class, I'm going to tell you that this thing here factors. I haven't learned yet how to factor it, but you know the distributive law. And this could be x plus 3 multiplied by x plus 2. If you use the distributive law, you see that x times x gives you x squared. Then 3 times x gives you 3x. And this 2 times this x gives you 2 more x. 3x and 2x gives you 5x. And 3 times 2 is 6. Now, if you can't see that just looking at it, it's okay. We're going to practice with that sort of thing a little bit later. Okay, just in a little while. If this was an equation going a little further ahead, just to give you a preview, if this equation had this equal to 0, then, of course, we'd say that both of these expressions, which are equivalent to this one, would both be equal to 0, right? Now, again, previewing a little bit, but get your mind thinking on this a little bit because it's important. If you multiply 3 numbers and get 0, what does that tell you? It says one of those numbers has to be 0, maybe more than one, okay? Well, this means that if x equals 0, you have a solution, right? If x is 0, you plug it in, you get 0 times 6, that's going to be 0. Or x plus 3 equals 0. Because, of course, if x plus 3 is 0, the whole thing comes out 0, right? Or x plus 2 equals 0. Well, x equals 0. X plus 3 equals 0. You can subtract 3 from both sides. You get x equals minus 3. But you can just see that if x is minus 3, that's going to give you 0. Okay? So you can do that almost by inspection, but if you need to do algebraic steps on it, you can do this. Okay? I mean, if you need to do algebra, you can add -3 to both sides. And here, x equals -2. So there are 3 solutions to this equation. Now, if you plug 0 in for x, all 3 of these things are going to be 0. If you plug in -3, -3 cubed is -27. X squared is 9. 5 times 9 is 45. And 6 times -3 is -18. -18 and 27 gives you 45. I didn't say that, right? -18 and -27 gives you -45, and this is 45. So you can't do those numbers in your head. I can barely do it, apparently. So if you plug 3 in, it's going to work. If you plug in -2, it'll work. You're going to get -8, you're going to get 20, and you're going to get -12. -8, -12, -20, add that to 20, you get 0. Okay? Then you could write that out easily. All right, so yeah, we're kind of gonna go here today. Try to figure out how to solve this equation, how to factor this, and how to find the two factors. Okay? Now, the second equation is x squared y to the seventh minus 3 x to the fourth y to the fifth plus 5 x to the sixth y to the eighth. What can we factor out? We have x squared, x to the fourth, and x to the sixth. The least power of x is 2. Every term has at least an x squared in it. And no term has an x, this term doesn't have an x cubed, so we couldn't factor out x cubed. And y powers are 7, 5, and 8. Well, the least power there is the fifth. Okay, so now if we factor x squared out of x squared, we just get 1. Okay, so we've already got x squared. Whatever we multiply by here is going to give us x squared, and we don't need any more x's. To get y to the seventh, we have y to the fifth. Well, we need a y squared in order to get y to the seventh. So again, x squared times y to the fifth. Y to the fifth times y squared is y to the seventh, and we already have the x squared. So we've got this term. Okay, to get this term, we're going to need minus 3. And we're going to need an x squared, because we got x squared. We need x to the fourth. We need 2 more powers of x. And we've already got y to the fifth, so we're not going to need any y's here. If we multiply this by this, we're going to get this. And then similarly, we need 5. We need x to the sixth. We've only got x squared, so we're going to need another x to the fourth. We need y to the eighth. We've only got y to the fifth, so that's going to be y cubed. There's not much more that we can do with that, at least nothing that I can see, obviously. And it would be rare. It's something that I made up just with random numbers, would actually have something in here that would factor. Okay. And what about this? Well, we know we can factor out an x cubed. And we know we can factor out a y squared. You know, since nobody got to this problem, I'm going to change the problem a little bit. It's something not unusual is going to happen here, but I'm going to change the powers of y. Okay, I'm going to make this one y to the sixth and this one y squared. So this is now y to the sixth and this is y squared, just changing the problem. Okay, so we can factor x cubed and we can factor out y squared, right? But it's got to be in the denominator, because our y's are in the denominator. Does that make sense? And what's that leave us? Well, the denominator is going to have y to the fourth. You can't just have a blank numerator, although we don't need any more x's. We got to have something to multiply by x cubed in order to get x cubed. What would I multiply by x cubed in order to get x cubed? Well, I multiply by 1. Okay, so now you can see that x cubed times 1 gives you the x cubed, and y squared times y to the fourth in the denominator gives you y to the sixth in the denominator. So if you got denominators, it's okay. You can deal with it. You just got to treat the numerator and denominator separately, just because of the rules for multiplication of fractions. Okay, then we have x cubed in the numerator. We need x to the fourth. So we're going to have an x in the numerator. We have y squared in the denominator. We need y squared. So our denominator here will be just 1. Y squared times 1 gives us y squared. So we get x cubed over y squared times 1 over y to the fourth plus x. We don't have to write the denominator 1. X over 1 is the same as x. All right. So this is a little bit new. You want to think about it. And you're going to encounter things like that. You're going to encounter expressions of that nature. So I'm going to show you a factoring trick. Let's say we've got two x cubed plus 5x squared plus 10x plus 25. Now there's no monomial that you can factor out of this. There's not one single term as there would be here or here or over there. It'll divide into every one of these. But I can do this little trick. I notice that if I skip one of these, take this one and this one, that 10 is 5 times 2, right? So this number is 5 times this number. And we do the same thing with these two numbers. This number here is 5 times this number. So I can rewrite this with these two expressions grouped together. So that now the two underlined expressions are together, and the two circled expressions are together. Now, what can I factor out of this expression? And what can I factor out of this expression? In other words, I'm going to treat these as two different expressions right now. I'll say, okay, we got this thing and we want to factor that. We got this thing and we want to factor it. Can you factor this and then factor this? Factor a monomial out of this, factor a monomial out of the other one. Okay, now I think everybody understands that we could factor a 2x out of this expression. If 2 goes into 10, so we can factor out a 2. We can't factor out anything bigger than 2 because we get 2 right there. And we can factor out an x. We got an x, and of course we have an x cubed. So we can say that this is 2x times x squared plus 10 added to, well, here, there are no x's on this term, so we can't factor out any x's, but 5 and 25, we can factor out 5. And I said x squared plus 10 here. It's 5. 2 goes into 10 5 times, right? In other words, 2 times 5 is going to give you 10, and you've got your x, so you're going to get 10x. You multiply 2x by 5, you multiply 2x by x squared, you get 2x cubed. Okay. And here, clearly, if you multiply this out, 5x squared, 5 times 5 is 25, everything checks out. Well, now there's something you can factor. I'm going to give you a minute and see if you can figure out what you can factor out of these two terms. Just a minute, because you're either going to see it or you aren't. Then when I show you, hopefully you'll start seeing it. We'll do some examples. Okay, this is not easy to see. I remember not understanding this at all when I first saw it. Okay, back in early high school. But I don't think many other people, if I didn't see it, most other people weren't going to see it. I could name 2 or 3 people who might have. Okay. So it's a little hard to see. So if you didn't see it, don't feel bad. I'm not sure you want to be in my company, but you're in my company on that. Okay. We can factor out an x squared plus 5. Okay. So we can make this as I'll write it this way just to make it as confusing as possible. Since the x squared plus 5 is on the right-hand side, it doesn't matter whether the thing we factor is on the right or on the left. Okay, so I'm going to just write it on the right. Okay, but you can verify that if you multiply this out, you're going to get 2x times x squared plus 5. That's what the distributive law tells you, plus 5 times x squared plus 5. So this is just a simple instance of the distributive law, only one step of the distributive law. So if you multiply this out, it's 2x times x squared plus 5, there it is, plus 5 times x squared plus 5, there it is. Okay, that's kind of slick. But I know when I first saw it, I didn't like having to look for that in an expression. Okay. Still, it can be very useful, powerful method of factoring. Okay, so we're going to look at it, partly because it really helps show you what the distributive law means and some of the things you can do. And partly because it can be useful. Okay, so let me give you another one. You see how this one works out. Okay, following the lead that we did up here, where we saw that qx cubed and 10x, we could factor something out of that, which is 2x, and we could factor something out of 5x squared plus 25, namely 5. And in both cases, we end up with x squared plus 5 in parentheses. So since this is the same as this, we can factor it out. And we can write this in this way. Again, if you use the distributive law, you know that if you expand this expression, you're going to multiply 2x by x squared plus 5, which is going to give you this. And you're going to get 5 times x squared plus 5, which is going to give you the 5 times x squared plus 5. Then if you expanded this up here, you get this. Then if you rearrange it, you could work it backwards. You could expand this, simplify it, and it's going to end up being the same as this. Okay, so that's what we're trying to do here. Now, we notice that 4 goes into 12 3 times, and 9 goes into 27 3 times. That's a good start. So maybe we go ahead and write this out and see if it's going to work. So we can put the 4x squared and the 12x, 4x to the fourth and 12x squared grouped together. And we can group the 9x cubed plus 27x together. And now let's see what factors out. From this term, we could write this as 4x squared times x squared plus 3. And on this one, we could write this as 9x times x squared plus 3. It all works out. So again, we've got the same thing here as we have here. So we can factor the x squared plus 3 out of this expression, giving us 4x squared plus 9x multiplied by x squared plus 3. And then we can check it. And I really strongly encourage you to check when you get something factored. You multiply it back by the distributive law and see if you get back to the thing you started with. That tells you whether you did it right or not. If you don't know whether you did it right or not, just write down an answer. Put that answer into open math or on a test. Okay? Well, open math is going to tell you you're wrong. It's going to cost you, some fraction of a point. So you're going to have to try again. Okay? If you check yourself and it works out, then chances are you did it right and you're going to get full credit. Okay? On a test, if you get it wrong, it's wrong. And if you didn't check it, it's wronger than it is if you did. Okay? I reward checking. Doesn't mean I'm going to give you full credit if you check, but if it's wrong and then you've checked it, any penalty I would have given you, if you haven't checked it, it's going to be a little bit less. Okay, so instead of getting 3 points out of 10, you might get 5 or 6 points out of 10. You just made some trivial little error and basically have the process right. I give you partial credit. Okay. Well, next factoring by grouping, you're going to have, I think, 7, maybe 9 problems of that type. And again, I keep repeating this. Do the problem completely by doing the check. If you don't do that, chances are you're not going to learn it very well, and you're not going to have it when you need it on a test or in a future course. Okay? Now, in a future course, you might have forgotten it, but if you learned it pretty well enough to do it on the exam, then it'll come back to you pretty easily. All right. So what you're doing here is you're trying to prepare for a transfer level course. Do it right. Take the time to do it. And I think you're going to be successful. Okay. Now, you remember I alluded to another topic. On this, the expression, the one we had here, we had an x in common, so we factored out the x. And verify, always verify. If I multiply this out, do I get this? Well, you will verify it, and you do. Okay. Then I said that x squared plus 5x plus 6 equals x plus 3 times x plus 2. How in the world did I know that? Well, I think I've known this one all my life. Okay, but sometimes I've got to think a little bit when they get more complicated. Not all my life, but 80% of it, 85%. Okay, so anyhow, you can verify if I multiply this by this, I get x times x, which gives me the x squared. I get x times 2, which gives me 2x. Then I get 3 times x, which gives me 3x that I can add to the 2x and get 5x. And 3 times 2 is 6. Well, we're going to look at that in a little more systematic way. Okay, I'm going to just analyze that one first. Okay. x squared plus 5x plus 6. Can we write that as x plus something times x plus something else? Okay, and I'm going to write that as x plus a times x plus b. Now, I'm not going to expand that, but I'll probably do that in another example. What we can see is the only way we're going to get 6 is if this number times this number equals 6, right? Because when we expand this, we're going to be multiplying a times b. Anything else that we multiply is going to have at least one x in it. A times b has to be 6. The possibilities from A and B are as follows. A equals 1, B equals 6. A equals 2, B equals 3. Or maybe A equals -1 and B equals -6. A equals -2, B equals -3. In every one of these, A times B equals 6. 1 times 6 is 6, 2 times 3 is 6, -1 times -6 is 6, and -2 times -3 is 6. Okay? So we try these, try different ones. What's x minus 2 times x minus 3? Well, that equals x times x minus 2 minus 2 times x minus 3. Using the distributive law, this times this minus this times this. And what does that equal? That equals x squared minus 2x that should be x minus 3. It's x minus 2 times x minus 3. I knew I'd written something wrong. But I couldn't find it. Once you write it down, it's like invisible. Okay, so apologize for that. It's this times x minus 3 minus 2 times x minus 3. And that gives you this. And you've got a minus 3x and a minus 2x. It gives you minus 5x. Gives you x squared minus 5x plus 6. And you want x squared plus 5x plus 6. Now, how in the world did we get a minus there? Well, we had a minus 2 here and a minus 3 here. That gives us 6. -2 times -3 gives us 6. But both of these are negative, and this is positive, right? Well, we could try. One thing this tells you is if you want a positive here, you don't use negatives on both of these. Okay? But maybe you could use a negative on one of them. Let's try another one. Let's try A equals No, we'll try A equals 1, B equals 6. It's at the top of the list. So that gives us, make sure that's an equal, looks like it's got a negative on it. X plus 1 times X plus 6. Well, multiply that out and see what you got. Use the distributive law. You write that 6 a little more clearly, parentheses a little close. So multiply X plus 1 times X plus 6 using the distributive law. Okay, some people got it, some people are on the way. Multiply this, and you need to understand this. We need to multiply X by X plus 6 plus 1 times X plus 6. The X multiplies the X plus, I mean, this term multiply, or this factor multiplies this factor. That means that this term multiplies this factor, and this term multiplies this factor. So there is your distributive law, and that gives us X squared plus 6X plus X plus 6, which is X squared plus 7X, doggone it, plus 6. Well, we've got a 7 here. We need a 5, right? In order to get this. Again, we're not going to try two negatives, because if both of these numbers were negative, just like down here, you're going to end up adding two negative multiples of X. You're going to get a negative multiple of X. Okay. So we're left with this possibility, which I intentionally left to last. This is going to work. Plug in A equals 2 and B equals 3 into this expression and see if it equals this. Okay, so if A equals 1, or A equals 2 and B equals 3, and keep your fingers crossed, because that's our last hope. Okay? We have no hope if we've broken down 6 in every possible way. Okay? So we get X plus 2 times X plus 3. And that's X times X plus 3 plus 2 times X plus 3. And that's going to be X squared plus 3X plus 2X plus 6. And if I add the 3X and the 2X, I get X squared plus 5X plus 6. And that worked. Okay. Now, I will tell you, Open Math gives you kind of an algorithm you can use. It's a good algorithm, but 6 weeks from now, when you have a final exam, more like 5.5 weeks, you're less likely to remember that algorithm than you are to remember this trial and error method. So I recommend that you try to reason it out this way. If you do, pretty quickly, you'll see how things need to fit together. Okay. Let's try another one. let's try. X squared plus X plus 3. Okay, if this is X plus A times X plus B, then again, A times B has to equal 3. Nobody ever does it, but I do recommend that you write out the steps as I've written them out, so you reinforce what you're doing. So go ahead and list possibilities for A and B. One other thing I'll mention. In this case, I could have listed A equals 6 and B equals 1. But that's not going to make any difference because you're still going to be multiplying X plus 1 and X plus 6. Okay? So it doesn't matter in which order you multiply X plus 1 and X plus 6. So let's just make it kind of a rule. When we have a monic expression with a 1 in front of X squared, then we'll let A be the number with a less absolute value. Okay? 1 before 6, 2 before 3. And -1 before -6, -2 before -3. So what are your possibilities for X squared plus X plus 3? Okay. Most of you have A equals 1, B equals 3, A equals -1, B equals -3. I actually kind of cheated over here. Well, actually I didn't. Never mind. Okay, those are the only ways those are the only integers that you can multiply and get the 3. Okay, so we try A equals 1, B equals 3. So we try X plus 1 times X plus 3. Now I'm just going to go through this kind of quickly because this is straightforward. Once you realize that you're going to try 1 and 3, you plug them in. And you get X plus 1 and X plus 3. And then you use the distributive law, X times X plus 3 plus 1 times X plus 3, and you get X squared plus 3X plus X plus 3. Well, you've got an X and an X here, but you've also got a 3X, and you've got to simplify this. This won't equal this because it's got that extra 3X in there. You get X squared plus 4X plus 3. I'll just write nope. That doesn't equal X squared plus X plus 3. Well, -1 and -3 aren't going to work either. Okay? Because if you use -1 and -3, you're going to have a -3X and a -X. All your X's are going to be negative, so you're not going to get a positive X out of that. Okay? The -1, -3, negative multiple of X, you're stuck. So You can't factor this over the integers. In fact, this is an expression. It can never be zero, but we haven't really talked about that, so I'm going to just not mention that. Okay. Okay, let's try x squared plus x minus 2. Now you want to write out the x plus a times x plus b thing, so I'll just write it out quickly. So you want two numbers that'll multiply out and give you -2. So list the possible pairs of numbers for a and b, and it will give you -2. Okay. Now, we've got it down to where we've got to find a and b that multiply out to -2. We can't use -1 and -2 because this times this would be +2. And we wouldn't have a -2. But we could do a equals 1, b equals -2. That multiplies out to -2. Or we could have a equal -1 and b equals 2. Those are the two possibilities. Well, if I multiply x plus 1 by x minus 2, I get x times x minus 2 plus 1 times x minus 2. And I really recommend that you write it out like this instead of doing little arcs. Okay? It's equivalent, but if you're trying to factor by grouping and you're not aware of this way of writing it out, you're going to have a little more trouble. There are other places where you really need to be able to see what's going on with the distributive law. Plus, if you try to multiply trinomials and stuff like that, okay, you want to be able to write it out. So write it out like this, as most of you are doing. Anyhow, that gives x squared minus 2x plus 2 plus x minus 2, which is minus 2x plus x is minus x. Okay? Well, that works out just great, except for the minus sign on the x. So this doesn't match this. But if we switch signs, multiply x minus 1 times x plus 2, well, we get x times x plus 2 minus 1 times x plus 2, which is x squared plus 2x minus x minus 2, which is x squared plus x minus 2. And that checks out just fine with what we started. Okay? Now, as I say, Open Math is going to give you an algorithm. I'm not even going to talk about that algorithm. Okay? You can do the homework using that algorithm, and it's a good exercise. It's a good algorithm. It's a good method for finding a solution if you can't do what I just showed you. But ask yourself, are you going to remember how to use that algorithm 6 weeks from now? If you understand what I've showed you here, you're going to remember that. Now, if you remember that and know the algorithm, then that's excellent, okay? And it's going to be okay, whichever method you use on the exam. If you use the algorithm, I'm going to say, well, good. You remembered a fairly complicated, it's not all that complicated, it's a fairly easy algorithm. You remembered how to do it using that algorithm, okay? If you don't remember how to do it at all, of course, you're going to miss these problems. All right. So use your own judgment. If you think you can remember how to do it the way Open Math shows you to do it, okay. But I encourage you to know how to do this as a fallback in case you forget the algorithm. And I encourage you to do this and the algorithm when you do the problems. Okay? You'll learn it better. You'll learn more if you do both. All right. Yeah, I think we're right about on time. Actually, we're not. We're 3 minutes early. I hate to let you go 3 minutes early because I'm afraid you're going to go out and get in trouble. So tell me you're not going to go out and get in trouble, and we'll just call this a day. Okay? Have a good weekend. Good luck on the homework.